Hello, we are here for the first lesson of a new video training course, and this is focused in another application of the suite we have inside T-FLEX. In this particular case, it's T-FLEX analysis. It's another module. We have already done a couple of videos for the CAM, a complete course. We've done also presentation videos for the nesting and for the dynamics. Now we are going to start a full course in this T-FLEX analysis. A brief presentation about this analysis. This is fully integrated inside T-FLEX. So as you can see, we are inside the environment. Even that all the previous videos we've done about T-FLEX, independent of the modules, were done in the 15 version, and this new course for this analysis module will be done on the brand new 16 version. But as you can see, the environment is pretty much the same. We have a specific menu for the analysis, so we have all these known menus, and we have this analysis module, which is pretty much the same as for the dynamics, but we have more functions and other functions because this has a different purpose. Okay, along the course we will see all the details about what all of these functions do inside this module, and among other topics that we'll see along these next upcoming videos. About T-FLEX analysis, this is an environment, specific one for finite element calculations. It is integrated inside T-FLEX CAD. With the help of this module, a user that is working with T-FLEX CAD can perform mathematical modeling of physical phenomena, and we can solve important practical studies arising from a daily design practice. All calculations rely on the finite element method, so what you know as FEM, and at the same time this associative relationship is maintained between the 3D model of the part of your assembly and the finite element model used in the calculations. So again, and we've mentioned this for the other different modules we have available in T-FLEX. This is a very big advantage because everything is integrated, so we can module and then go and create the calculation and go back, so it's quite simple. We have basically three groups available in this finite element module. So we have the static analysis, we have the dynamic analysis, and the thermal analysis. All of these is explained in detail on the training course, on the theoretical training course, but give you some brief highlights about it. The static analysis include four types of studies. One called the static strength, that allows the calculation of states of stress and strains in a structure under the impact of constant in-time forces applied to the model. We have the buckling. It's very important on the design of structures. We have the fatigue. So it's very important also in mechanics because certain parts of machines or mechanisms and structural elements during time are subjected to loads that change with time. And we have the express analysis, which is an evaluation module that it's available for static analysis, so simpler analysis. The dynamic analysis group offers several types also of finite element studies. Among them we have the frequency, This allows the natural frequencies of a structure and the respective vibration modes. We have the forced oscillations, and we use this to predict the response of the structure subjected to harmonical varying external loads. Another one called the mode superposition. This allows the simulation of the behavior of mechanical system under the loads that are not constant in time. On the opposition of this one, we have the transitional process, which allows the simulation of to simulate the behavior of a mechanical system in time. And finally, another group, thermal analysis, which can solve stationary thermal process, gives you the possibility to study stationary temperature field evaluation, and non-stationary, which, as the name says, allows the calculation of non-stationary processes in time. This, as you might understand, has a strong mathematical background to allow these calculations. I will not go inside very long descriptions about this mathematical background. It's only important, it is a brief note for your understanding that this mathematical background and this possibility to make these calculations can be described as mathematical equations that can describe mechanical behaviors of parts or assemblies, and this is the base of this T-FLEX analysis. We have also some requirements for your machine. So this is a heavy calculation process. So the best machine you can have for sure will help you to reduce time in obtaining results. So you can briefly see what is recommended for your machine. And to end, two more notes. First, to show you a very brief example of what we have in this analysis. First, we have this part where we have several conditions that you can see, for example, loads represented by these arrows and other elements represented by these yellow elements also inside this part. And we can have conditions here solved. So basically we can, I don't know what is done, so I will say simply solve. So I will say go for it. And in this solve we have results. So if we open this, we have studies. Okay, we have conditions for this, we have results, and we can go on the results, open them, and we have this kind of analysis. For sure we can export these for better understanding and to create a proper report, but this is the kind of information we can obtain to analyze what was calculated. Then we have conditions, animations, and so on. So we'll go on this in the next proper lessons. Finally, just to mention the steps of, generally speaking, the steps of a structural analysis. So we have to build a 3D model, as you understand, because this is the base for every calculation. We need to create also a study for creating the conditions that define the state to be calculated. We need to define materials for the elements. we need to create this thing that you can see in this part that is called the mesh, and we have several important topics about this mesh. We need to apply boundary conditions that reflect the essence of the physical phenomenon that is going to be analyzed. Then, after all of these conditions done, we run the calculations, and after we analyze the results. So these are basically the steps that we need to go to use properly this T-FLEX analysis. So this is the first lesson. I hope that this introduction will help you for now to have a better highlight of what we can have in this analysis, and be with us for the full course and the complete set of videos that we are going to release in the next upcoming weeks.